You know, our world is run by invisible forces. Some are gentle, like the vibrations that let us hear a song. But others are so powerful they can tear entire cities apart. In this explainer, we're going to dive in and uncover the hidden physics behind some of the most dramatic events and, frankly, some of the most surprising inventions on Earth. And we're going to connect them in a way you'd probably never expect.
So, here's the central question. What in the world connects a collapsing bridge to liquid body armor? It sounds like a riddle, right? I mean, what could possibly link the catastrophic failure of this massive steel structure with a super futuristic material that can literally stop a bullet? Well, the answer reveals a fundamental truth about how we understand and engineer our entire world.
Just look at these two images. On one hand, you have the complete twisted failure of a man-made bridge, and on the other, the raw, swirling power of the atmosphere. Both of these are the visible effects of invisible forces being pushed to their absolute breaking point. And trust me, by the end of this, you'll see exactly how they're related.
All right, let's start with a force we all experience every single moment of our lives, usually without even thinking about it: vibration. And it's not just for machines and guitars, it's fundamental to our very existence.
I mean, really think about it. The only reason you're hearing my voice right now is because your eardrums are vibrating. We speak because our larynges oscillate. Even something as basic as walking or breathing, that's all just a form of periodic vibratory motion. It's like this constant rhythmic hum just beneath the surface of everything we do.
So what are we really talking about? Well, the core concept is incredibly simple. If a motion repeats itself over and over again, it's a vibration. A swinging pendulum, a plucked guitar string, the gentle rise and fall of your chest, it's all the same fundamental principle at work.
Okay, but this is where things get really interesting and pretty dangerous. That simple, repetitive motion, it has a hidden power. And under just the right conditions, a tiny, almost insignificant vibration can get amplified into an unstoppable, destructive force.
The key concept here is called resonance. The best way to think about it is like pushing a kid on a swing. If you push at just the right moment in each swing, matching its natural rhythm, its natural frequency, your small pushes make the swing go higher and higher and higher. Resonance is a force multiplier, and in the wrong situation, it can be absolutely catastrophic.
And that brings us right back to the Tacoma Narrows Bridge. See, it wasn't blown over by one single powerful gust of wind. Nope. Instead, a steady wind created these small rhythmic vibrations that just so happened to match the bridge's own natural frequency. And just like pushing that swing, the wobbles grew larger and larger until the entire structure literally tore itself apart. An invisible hum became a very, very visible collapse.
Okay, now let's totally shift gears. We're going to move from the huge, large-scale motion of structures to the microscopic world of fluids. And we're going to talk about a property you might remember from science class: viscosity, which is really just a fancy word for a fluid's resistance to flow.
Now, we usually think of fluids as having a fixed viscosity, right? Water is always watery. These are what we call Newtonian fluids. But a whole bunch of common substances are non-Newtonian. Their viscosity actually changes depending on the force you apply to them. The classic example is ketchup. It's all thick and stubborn in the bottle, but flows easily once you give it a good shake.
But what if a fluid did the exact opposite of ketchup? Well, there's a specific type of non-Newtonian fluid that does just that. It's called a shear thickening fluid. The most famous example is that goop you can make with cornstarch and water. You can slowly run your fingers through it like it's a liquid, but if you punch it, bam, it instantly becomes as hard as a rock.
And get this bizarre property isn't just a fun kitchen experiment. No way. As one Reddit user pointed out, this liquid that turns solid principle is actually being used to create a new generation of advanced body armor.
So how does this liquid armor actually work? Well, it's brilliant. The armor material is infused with one of these shear thickening fluids. Normally, the tiny particles in the fluid are just floating around, which makes the material flexible and easy to wear. But when a high-speed object like a bullet hits it, the sudden force instantly jams those particles together into what scientists call hydroclusters. For a split second, they form a microscopic traffic jam, creating a solid-like barrier that disperses the impact's energy before turning right back into a liquid. It's basically a shield you can wear like a shirt.
So we've seen how the invisible forces of vibration and viscosity can have some pretty dramatic effects. Now, let's scale up, and I mean way up, to the massive atmospheric forces that create one of nature's most terrifying displays of power.
Cyclones, hurricanes, tornadoes. At their core, they are all gigantic, rotating air systems. And just like that bridge and the body armor, they are born from a very specific set of physical conditions that turn a totally calm environment into a vortex of pure destruction.
And the consequences are just devastating. Unlike the focused failure of a single bridge, the power of a cyclone is spread out over vast areas, and it's capable of leveling entire communities. Understanding how they form is absolutely the first step to being able to predict them and protect people.
So, what's the recipe for one of these monster storms? It all starts with really warm ocean water. This warm water heats the air right above it, causing that air to expand and rise. When it rises, it leaves behind an area of low pressure. And, well, nature hates a vacuum, so cooler, higher pressure air from all around rushes in to fill that void. That rush of air is the engine of the storm.
But what turns all that rushing air into a spinning vortex? That's the secret sauce, and it's all thanks to the rotation of the Earth itself. It's called the Coriolis effect. Because our planet is spinning, that air doesn't just rush straight in, it gets deflected sideways. And that deflection is what creates the iconic spin. Counterclockwise in the north, clockwise in the south. Fun fact, this effect is weakest at the equator, which is exactly why these powerful storms almost never form there.
And the power that spinning generates is just immense. This table shows the F-scale for tornadoes. Just look at the jump in destructive power. An F1 can push a car off the road, but an F5, with wind speeds over 260 miles an hour, it can literally lift buildings clean off their foundations. The power is almost unimaginable.
Okay, so a vibrating bridge, a weird liquid that hardens on impact, and a spinning city-sized storm. Now let's bring it all together. What on earth is the common thread?
It really comes down to this. On the left, you see an engineering model, a system of pure logic, pure order, designed to be safe and predictable. On the right, you see the aftermath of natural chaos. The bridge between these two worlds, the way we manage to turn chaos into order, is by understanding the physics underneath it all.
By understanding resonance, we now build bridges with special dampeners that prevent those catastrophic vibrations. By understanding non-Newtonian fluids, we can create flexible armor that can stop a bullet. By understanding atmospheric pressure and the Coriolis effect, we build better warning systems and more resilient cities. That knowledge transforms a destructive force into a solvable engineering problem.
You know, the story of human ingenuity is really the story of seeing these invisible forces, taking the time to understand them, and then turning that knowledge into tools for survival and progress. The principles are all around us, just waiting to be discovered. The only question is, what are we going to learn to control tomorrow?